Okay, here are the answers to the spring break catch-up sheet number 3. And for those of you that have done this sheet, there is a mistake on here, so we'll get to that in a little bit. But first of all, here we go with number 1. All right. So we are told that the probability of A is 0.7. Probability of B is 0.6. And the probability of A and B is 0.4. So that's right here. This is A and B right there. If the whole A ball is 0.7, then this has to be 0.3. And if the whole B ball is 0.6, this has to be 0.2. But when we add these up, 3, 4, and 2, we come up with just 0.9. So there must be 0.1 out here. So there's the completed Venn diagram. Now we need to answer the questions, which say, what is the probability of A or B? Now, A or B, that's the union. That's everything in the circles. So this means everything in the circles. Make a note of that if you've forgotten. That means everything in the circles. So we have 0.3, 0.4, 0.2. So the answer to that one is 0.9. Now at this point so far, we haven't really needed to do this, but it might be smart now to think of these as the people who like apples and these as the people who like bananas. What does this say then? This says you don't like apples, you do not like apples, but you do like bananas. This is and. No apples and bananas. So the people who do not like apples but who like bananas are right here. This is where we're talking about. So that's 0.2. These people like bananas, but they do not like apples. All right, number 1 done. Number 2, we've got we have boys and girls and homework and no homework. And we have 10 and 16 and 24 and 6. Okay. So, for example, remember how to read this chart. These are the boys who do their homework. And these are the girls who don't do homework. Okay. So the question says, if 1,000 students are surveyed, how many would be expected to do homework? Well, the first thing you're going to want to do is find the homework probability. The probability of doing homework is what? Well, if you look here in the chart, there are 26 kids who do their homework. And there are a total of how many students? Let's see, well, there's 26 here and 30 here. So 56 students altogether do their homework. I know that reduces, but don't worry about it. You can if you want. It doesn't matter. It's not the answer to the question. The answer to the question says, if that's the probability that we will do our homework, 26 out of a total of 56, then if we apply that to 1,000 people, we're just going to multiply it times 1,000. And that is going to tell us how many of those kids can be expected to do their homework. So 26 divided by 56, 26 divided by 56 times 1,000. And we'll round that off. These are people, so we'll round it off to the nearest person. So it's 464 students will be expected to do their homework. So we found the probability of what we wanted, which was homework doing, and multiplied by 1,000. Now notice in this problem, gender had nothing to do with it. Our table was set up according to boys and girls, but we were looking at 1,000 students total. So we had to just deal with all of the students. Okay. Now we're going to pick 5 cards from a standard deck. And we want no jacks. Okay, now 5 cards from a standard deck means your denominator is going to be 52C5 because there's 52 cards and you are picking 5 of them. Now, how many jacks are in the deck? 4. So how many non-jacks are in the deck? 48. There's 52 cards altogether. 4 of them are jacks. We don't want to get any jacks, so we want to take the jacks out. So there are 48 non-jack cards in the deck. So our numerator is 48C5 because we want to pick 5 cards that aren't jacks. So it's like you have your deck of cards, pull out the 4 jacks and put them over here, and then you're picking from what's left. There are 48 cards left, and you're picking 5 of them. So 48 C5 divided by 52 C5, and it's 0.6588. You can answer decimally or with a fraction. Mine came up as a nice little decimal, so I'm going to answer as a decimal, 0.6588, but you certainly could answer with a fraction if you wanted to. All right. Now we have a frequency table. And we have 2, 4, 6, 7. So our data points are 2, 4, 6, 7. And the frequency, that is the number of times we have them, are 3, 1, 4, 9. So again, what this means is, if you wrote out your list of numbers, you would have 3 2s, 1 4, 4 6s, and 9 7s. So I'm not going to write all that out, but this tells you how many times you have each of those numbers. And your job is to find the mean. Well, to find the mean, you would just add all these up and divide by how many you have. Well, to add them all up, we have 3 2s. So that's 3 times 2, or 6. We have 1 4, so that's plus 4. We have 4 6s, so that's 4 times 6, or 24. And then 9 7s, so 9 times 7, or 63. So my total is 97. So 3 times 2, 1 times 4, 4 times 6, 9 times 7, add them all up. Now, how many numbers would be in this list? Well, there'd be 3 2s and 1 4, that's 4. 4 6s, that's 8. And 9 7s, that's 17. So your mean is 97/17, which is fine to leave it that way, but if you prefer to write it as a decimal, it'd be 5.71. That is your mean. Okay, now we have our bags of marbles. And I think I've burned out another marker. So here we go. All right, we're going to pick one from each bag, and we want 1 red and 1 green. So if we reach it, well, 1 from each bag. So we're going to take the red one out of here. So that's 0.2, red 0.2. And that means multiply. Green, yeah, green out of that bag, so that's 0.2. So that'll be 0.04. Now, here's where it's a little tricky. You cannot stop there. You cannot stop there because there's nothing in the problem that says I have to get red out of this bag and green out of that bag. What if I got green and red? Well, that would be okay because I'd still have a green and a red. So now green out of this bag is 0.4 and times red out of that bag is 0.1. So that's also 0.04. And since it could be this or this, I'm going to add those. And the answer to the problem is 0.08. Remember, and means multiply. So when we say red and green, we're going to multiply those numbers. But or means add. So when we have this answer or this answer, we have to add them together. 0.08. All right, here's the one where there's a mistake. And if you did it, you caught it. Quite obviously. All right, because we've got, what, 73 kids? In the gym. And what are they doing? They are biking, walking, and skipping. And there's 73 of them. And 31 of them love to bike. So we got 31 bikers. We have 35 walkers. And then we're going to have 29 skippers. That should be a 29. When I typed it, I apparently forgot the 9. So that should be a 29 that love to skip. 12 love to do all 3, so they go right there. 6 like just biking. 9 like just walking. And 10 like just skipping. We're going to pick a kid at random. And we want to know what's the probability of choosing a student who just likes skipping and biking, and what's the probability of choosing a student who doesn't like any of the activities. Okay, so let's fill in the Venn diagram first before we answer any of the questions. So let's call these X, Y, and Z. And let's set up our equations. So for the B ball, for the biking ball, we have X and Y. And 18 that have to be 31. So we have 18, we have 6 and 12, that's 18. And then X and Y, and that has to be 31. Which means X plus Y has to be 13. We subtract the 18 over. Okay, let's go to the W ball. We have X and Z, and 21, that has to be 35. So X and Z is 14. And then let's go to our S ball. So we have Y and Z and 22, and that has to be 29. So Y and Z is 7. So I kind of did my simplified equations as I went along. So the total of each ball is right here. We just simplify each equation. All right, so now I'm going to take these 2 equations right here, the first 2 I wrote, and I'm going to multiply the bottom one by a negative. And I'm going to add them together, so that will cancel. And I have Y minus Z equals negative 1. And then I still have my Y plus Z equals 7. Now I can add those together, and 2Y equals 6. So y equals 3. Now, if y equals 3, well, let's see, what have I got here? What have I got here? I've got 9, I've got 21, but it's supposed to be 31, so x has to be 10, because these all have to add up to 31. And now I've got 10 and 9 and 12. That makes 31, but it's supposed to be 35, so that has to be 4. Now let's do a double check. That's 15, 19, and 10. That's 29. So we're all good. Now let's total those up. Let's add up all those numbers. So 6 and 10 and 12 and 3 and 4 and 9 and 10. So let's add up all the numbers in there, the black ones and the purple ones, and see what we come up with. I got 54. Double check my arithmetic. Let's do that one more time, and just to make sure, since I made a mistake in the problem. Yeah, I got 54. So there are 54 people in the circles, which means that there are how many out here? Well, there's 73 kids in the gym altogether. So there are an extra 19 kids out here that aren't doing anything. Now we can answer the questions. So A says, I'm going to erase this right here. A says, what's the probability of choosing a student who likes just skipping and biking? So skipping and biking would be right here. These people right here. These are the skipping, biking people. So that would be 3 over 73. That's the probability of picking one who likes just skipping and biking. And then B is who doesn't like any of the activities. Well, that's these guys. So that's 19 over 73. And there are the answers to the questions. Okay, one more. All right. Oh, now we're in the weight room. Okay, so we got 42 kids in the weight room. 4 of them are injured. 27 are bench pressing. 23 are squatting. And then, okay, so we got kids benching and squatting, and we got 4 of them out here not doing either one because they are injured. So that means if there's 42 kids in the weight room altogether, but 4 of them are sitting out, there are only 38 kids that are participating. So we have 38 kids that are actually doing something. But when we total up the activities that are happening, there are 50 activities happening. So if there are 50 activities but only 38 kids doing it, there are 12 that must be overlapping. And since the whole B-ball is 27, if 12 of them are there, there have to be 15 here. And the whole S-ball is 23, there must be 11 of them here. Now do a quick check. 15 and 12 and 11 and 4. Does that add up to 42? It does. So now we can answer the questions. How many students did both lifts? Well, that's 12. So the answer to A is 12. 12 students did both lifts. Right there they are. If a student is selected at random, what is the probability that she did just one lift? Well, just one lift would be either just bench press or just squat. So that would be 26 divided by 42, which reduces to 13 over 21. So the answer to A is 12, and the answer to B is 13 21s. And that's it. Good work.